Welcome to the Q-munity Tutor tipvid on section 2, the various interpretations of quantum mechanics. And I'm going to talk about the Copenhagen interpretation, was the original interpretation, if you like, and it's still the most popular. It's amazing because the Copenhagen seems to be accepted where the many worlds is considered ludicrous. And the difference between the two aren't that great, but nevertheless, it all comes from the double slit. So I'm just going to explain quickly what happened there, which is still amazing. A lot of people don't realize it's over 200 years old. And that guy there is Professor Young. And what he wanted to know was, what is the empirical nature of light? Newton at that time had suggested it was a particle, which he called a corpuscle. But so Professor Young actually opened the curtains as slightly as possible to let a very small ray of sunlight in. He then aimed it accurately at a detector that had a couple of slits in it. I may add microscopic or very, very small slits, not like we see there. And then he had a back detector slit. And his thinking was, well, if light is a particle, it's as if you're firing a machine gun at the first slit, and you'd expect to see at the detector screen, you'd expect to see a clump pattern. Whereas if you pushed water through those two slits, they would form waves, they would interfere with each other, and you would get what's called an interference pattern, which is actually what we see here, with many lines, with the darkest lines being in the middle. And in point of fact, this is what happened. We found an interference pattern. So Professor Young went, great, light's a wave. Here's the proof, there's a interference pattern. And that was the way we looked at it for 100 years. Scientists all said light was a wave. And then along came Einstein in his Annus Miraculous, where he came up with 4 pivotal university-wide papers, one of which was the photoelectric effect, but it's actually proves that light is a particle. Now, Einstein said, look, I'm not saying Professor Young was wrong. He was right. I've looked at that experiment many times. It seems like light is a particle and a wave at the same time. So they then came up with the double slit, and they did it more accurately. And eventually, we got to the stage where we could send 1 photon through at a time. And that meant that we could actually, as it goes through the slit, what's actually happening so that it interferes. Because it interfered even when there was just 1 photon. It's like it interfered with it. It's like it split into 2 before it reached the double slit, went through the double slit together, and then interfered with itself. It was very strange. And by the way, that's supposed to be a high-speed camera that can catch 1 photon. It's the only graphic I could come up with. So the camera there, we put the camera directly on one of the slits to see what was happening. And amazingly, as soon as we did that, the interference pattern disappeared and it became the clump pattern. It's as if nature didn't want us to find out. Now, this is the Copenhagen. The interpretation of the Copenhagen is that they had to say light was a wave-particle duality. It was a wave and a particle at the same time. But the Copenhagen interpretation is that when it's measured, due to Heisenberg's uncertainty principle, we can't know the location and the momentum of a subatomic particle. So when it's measured, it collapses. Now, the Copenhagen, which was basically Niels Bohr, went on to say that it included quantum field theory, or at least a version of quantum field theory, the pre-runner of quantum field theory, where there is a quantum field, just like there is an electron field, a muon field, a tachyon field, an electromagnetic field, that's universal. So what the Copenhagen is saying is that when it's in superposition, the particle is in a probability wave. So it has a probability of being everywhere at any one time. But when it's measured, somehow, instead of being in everywhere, it goes to a distinct location in the quantum field, which we consider to be a particle. So that's the Copenhagen, but it is very strange. Something very strange is happening no matter what. 1 second, the wave particle in superposition is everywhere, and as soon as it's measured, it goes to one location in the quantum field. So let me talk about, I'm going to discuss one other point that sometimes is lost about the double slit. Something that's equally as peculiar. Let me explain. Okay, let's have a look at the double slit a little closer. Now, if we had the double slit here, and we had the back detector board here, and we had a light source firing electrons or photons, we'll call them photons, firing photons through the top slit. Now, what I want to do for this instance, for this peculiarity of the whole system, is let me block off the bottom slit. So now there's only one slit, and as I say, it's as if we're firing a machine gun. The electrons, some will go through, most of them will go directly to, to the other end of the wall, if you like. And because of diffraction, a lesser amount would go just slightly above it, and a lesser amount would go slightly below it. So if we were to plot the frequency, it would look something like this, with most of the photons hitting the backboard directly opposite the slit. And that's what we've done in experiments, and that's what happens. But let's see what happens when we open the other slit. Okay, well, something very peculiar happens when we open the bottom slit. And what we find is that this interference pattern occurs. This, as we know, this strange interference pattern occurs, which is like this. And if we compare that with what we had before, it's amazing. If we look at this point here, when we had one slit open, so this is one slit, this is the double here. When we had one slit open, this had not the maximum number of hits, but it had, second or third highest number of hits. It was hit very frequently. That's this point here. But when we have the second slit open, it's actually a low number. The number has decreased. And the Copenhagen tries to answer, why would that number decrease just by opening a slit way down here? So again, this is just one more thing that is this very strange peculiarity that happens in the double slit. And the Copenhagen interpretation tries to explain it away. Thank you very much. I hope this has helped in some way, and I look forward to talking to you in the next session.